Today we're going to talk about division. When dividing fractions, division is the inverse operation of multiplication. Any division is the inverse operation of multiplication. Remember, we cannot divide by 0, so 0 in the denominator doesn't work. When dividing fractions, we take the reciprocal of the second fraction and then multiply. Again, just like with multiplication, it's much easier to factor all the numerators and all the denominators first and divide out any common factors and then do your division. Then if there is a factor in the numerator and denominator, divide it out. And again, this way you won't get really large numbers that you need to reduce. The reciprocal is when two numbers are multiplied. You have two numbers, and when they multiply together, they equal 1. To obtain the reciprocal, you need to flip the fraction, basically. Let's see how this is done. So the reciprocal of 6 over 15 is 15 over 6. The reciprocal of x minus 7 over x plus 4 is x plus 4 over x minus 7. The reciprocal of 15. 15 is the same as 15 over 1. Those two are equal. So the reciprocal is 1 over 15. The reciprocal of negative 3/5, we're going to keep that negative and flip the fraction, so it would be 5/3. The reciprocal of 1/6 is equal to 6 over 1, which is 6. The reciprocal of 1/6 is 6, not 6 over 1, because 6 over 1 is equal to 6. And the reciprocal of y over 4 is 4 over y. So the reciprocal is actually the same as a fraction to the negative 1 power. When we take the negative 1 power, we take the reciprocal of that fraction. So now we want to talk about division. The first thing we want to do is divide 280 divided by 4. This fraction line means divided by 4. Think about if we wrote 280 divided by 4. This is the 280 goes up here and the 4 goes down here. That's what those two dots are for. So 280 divided by 4. So how many times does 4 go into 280? There's a couple different ways you can do it. 4 goes into 28 7 times, and so it would be 70. Or you can do it by long division. 4 goes into 28 7 times, multiply down, and we have 28. Add 0, and this extra 0 we just need to add here. Because division is an inverse of multiplication, we can actually check our answers by multiplying. $70 times 4 is 280, so it checked out. Now we just found out that 280 divided by 4 equals 70. Now we have 280 divided by 0.004. So the first thing let's do is get rid of the 004, get rid of the decimal in the denominator. So we're going to multiply by 1,000 because this is 4 1,000ths. Going back, if we're multiplying by 1,000, we're adding 3 zeros, so 280, and then 3 more zeros. And then this one, the decimal point moves over 3, so it's just 4. So now we have 280,000 divided by 4. That is going to be 70,000. Because we did 280 divided by 4 was 70, and then we still have our 1,000 there. So 5/7 divided by 5/8. You want to take 5/7 times the reciprocal of the second fraction. So 5/7 divided by 8/5. Our 5s are common factors, that one's in the numerator and one's in the denominator, so that those divide out and we end up with 8/7. Now we have 16 over 5x plus 15 divided by 8x over x plus 3. So the first thing we want to do is factor as much as we can. So it's 16 over, here we can factor out a 5, and we have x plus 3 divided by 8x over x plus 3. Now we want to take the reciprocal of the second fraction, so that's 16 over 5 times x plus 3 times, when we take the reciprocal, we change it to multiplication, x plus 3 over 8x. So then that's technically one term, one number, so the x plus 3 is in the numerator and the denominator, those divide out. And then we have 16 and 8. 16 divided by 8 is 2, so that divides out. And then we can multiply across the numerator and denominator, and we have 2 over 5x. Same thing again, we're going to factor everything. So 9 minus x squared is 3 minus x times 3 plus x over, we have x minus 3 times x plus 1 divided by, this one's going to be x plus 3, x plus 2 over x plus 2 times x plus 1. Now we're going to take the reciprocal of the second fraction and multiply. So we have 3 minus x, 3 plus x, x minus 3, x plus 1, times, because we're taking the reciprocal, x plus 2 over x, or times x plus 1, all over x plus 3, x plus 2, and now we can divide out our common terms. So there's an x plus 2 and an x plus 2 in numerator and denominator. Remember, 3 plus x and x plus 3 are the same, so those can divide out. And we have x plus 1 and x plus 1. We'll put an equal sign on these because they're all equal, and then I'm going to come over here. So that's equal to 3 minus x over x minus 3. Now remember, those are very similar, and 3 minus x, let's go up here off to the side, 3 minus x is equal to minus x plus 3, and then we can factor out a -1 and have -1 x minus 3. So this is -1 times x minus 3 in the numerator, and then x minus 3 in the denominator. Those x minus 3's divide out, and we're left with -1. Divide this. These are both in scientific notation, so your final answer should be in scientific notation. Just like with multiplication, we can divide the numbers, the 4.5 and the 5, and then we can divide the powers of 10. So 4.5 divided by 5. If we're dividing in decimals, we can put the decimal point up here and then ignore it. So 5 goes into 45 9 times. So our 5 divided into 4.5 is 0.9. So we have 0.9. That's the same as 9.0 times 10 to the negative 1 if we're writing in scientific notation. So now we have, and then we want to do 10 to the 14th divided by 10 to the negative 21st. That's 10 to the 14th minus negative 21. So that would be 10, 14 plus 21 minus a negative is plus, would be 10 to the 35. So we have from our first part, we have this. We have 9.0 times 10 to the negative 1. And from our second part, we have that. So we're multiplying again by 10 to the 35th. And again, we have to add those exponents. So our final answer is 9.0 times 10 to the 34th. Now we want to divide these two. Let's change this to a positive because we haven't talked about having roots of negative numbers. The only time you're going to have to deal with that is if you're going into Math 105. So we'll change it to the square root of 27 over the square root of 48. The first thing you want to do when you're doing these is see if there's a common factor. Is there something we can divide out? Sure enough, they both have a 3, so we can divide numerator and denominator by 3, and we get the square root of 9 over the square root of 16. The square root of 9 is 3, and the square root of 16 is 4. This is one-term division. Notice there's one term here. When it's one-term division, we can divide each individual term in the quotient divided by the divisor. So if it's one term, there's no plus or minus or anything after this, we can do 42x to the 4th divided by 6x cubed minus 21x to the 3rd over 6x cubed plus 15x squared over 6x cubed. So now we have 42x to the 4th over 6x cubed. 42 divided by 6 is 7. X to the 4th divided by x cubed is just x. And then minus 21 divided by 6. We can take a common factor of 3 out and have 7 halves, and then x cubed divided by x cubed is 1, plus 15 divided by 6, we can take a common factor of 3 out, and then we have x squared divided by x cubed, and we'll have an x in the denominator, so we'll have 5 over 2x. So our final answer is 7x minus 7 halves plus 5 over 2x. This now has two terms. So with two terms, we want to use polynomial long division. We're going to mirror regular long division with polynomial long division to see our similarities. So the first thing we want to do when we set up long division is do 23 divided by 4,521. So here we're going to do x plus 3 divided by 6x squared, or divided into plus 12x minus 13. This goes down x squared, x, and then no x's, and that's what you're going to want. We'll show another example. So our first step for this is how many 23s go into 45. There's one 23 that goes into 45, and then you multiply 1 times 23 to get this. And a lot of times you forget this, but we're actually subtracting, and we have 22. So let's do the same thing over here. Only this time you only have to look at the x's. How many x's go into 6x squared? Or what do I need to multiply x by to get 6x squared? We need to multiply by 6x. Same thing here, we put the 1 over the 5 because that's where we're gonna, that would be our place value. The same thing here. The place value is our x. So now we do 6x, then over here we did 1 times 23. So now we're gonna do 6x times x plus 3 times this whole thing. So 6x times x plus 3, remember we have to distribute our 6x. So we have 6x squared plus 18x. But just like over here we subtracted, we're subtracting this whole thing. So we're subtracting the 6x squared and we're subtracting the 18. And then 6x squared minus 6x squared is 0. 12x minus 18x is minus 6x. And now over here, we're going to bring down our 1. So over here, we're going to bring down our minus 13. Then we say how many times does 223 go into how many times does 23 go into 221? That would be 9, maybe? I'm not sure. So let's do 23 times 9. That would be 7. Carry the 2, 18, 20. So 207. So that, yep, 9 times. So then 207. And we subtract. We have 14 left over. So 23 goes into 4,521 19 times with a remainder of 14. So our answer is 19 and 14 over 23. So then let's finish up over here. How many times does x go into minus 6x? Minus 6 times. And then again, remember we're multiplying minus 6 times this whole thing. So you have minus 6x times minus 6x minus 18. Because negative 6 times positive 3 is negative 18. But again, this is the one that everybody forgets. We're subtracting. So when we subtract a negative, we add a positive. These were both minus, so we're actually adding them. Over here, people just naturally do the subtraction because they've done it so many times. Over here, we forget because we have x's in there. So then that's why I always change my signs. Negative 6x plus 6x is 0. Negative 13 plus 18 is 5. So our answer for this one is 6x minus 6 plus 5 over x plus 3. This is the quotient and this is the remainder. So let's practice some more polynomial long division. Again, this goes x cubed, x cubed, x squared, x, and then no x's, so we're in the right order. So we don't have to do anything there. So then we have 3x minus 4 divided into 12x cubed minus 13x squared plus 14x minus 17. How many times does 3x go into 12x cubed? It goes in there 4x squared times. and then we multiply down. 4x squared times 3x minus 4 is 12x cubed. 4x squared times minus 4 is minus 16x squared. But we're subtracting, so let's change our signs. And then actually do the subtraction. 12x cubed minus 12x cubed is 0. Negative 13x squared plus 16x squared is 3x squared. And then we bring down our next term, so 14x. How many times does 3x go into 3x squared? It goes in there plus 1x times. You don't need that 1. Sometimes it helps people though. 1x times 3x is 3x squared. 1x times minus 4 is minus 4x. Again, we're doing the subtraction. So we have to change our signs. And do our subtraction. 3x squared minus 3x squared is 0. 14x plus 4x is 18x. And then we bring down our last term. How many times does 3x go into 18x? It goes in there plus 6 times. And multiply down. 6 times 3x is 18x. 6 times negative 4 is minus 24. Subtract, so we change our signs. And we have 18x minus 18x is 0. Minus 17 plus 24 is plus 7. So our answer is 4x squared plus x plus 6 plus 7 over the divisor, which is 3x minus 4. This one has x cubed, and then there's no x squared term, and then x, and then there's no x term. So when we're setting this up, we want to do 3x plus 2 into 9x cubed plus 0x squared, because there's no x squared term, plus 11x plus 10. We can always add 0. And now we can do the division. 3x goes into 9x cubed. 3x squared times 3x squared times 3x is 9x cubed. 3x squared plus, or 3x squared times 2 is plus 6x squared. Subtract. And we have minus 6x squared. Bring down our 11x. So how many times does 3x go into minus 6x squared? It goes in there minus 2x times. Multiply down, and we have minus 6x squared minus 4x. And we have to subtract. So we change our signs. So that cancels out, and we have 15x. Bring down our plus 10. 3x goes into 15x plus 5 times. So then we have, multiply down, we have 15x plus 10. And we're subtracting. So we change our signs. And 15x minus 15x is 0. 10 minus 10 is 0. So this one has no remainder. It divides evenly. So this is equal to 3x squared minus 2x plus 5. And now I completely forgot that we need to check all our answers. This one has a lot of stuff. We can erase the first long division. Polynomial long division has a lot of steps, so you want to be careful and check your answer to make sure that you're correct, because it does take a lot of work. So if you check your answer and you know your answer is right, then you can enter it and you'll be confident that you're right. So to check our answers, we check with multiplication. So we're going to do x plus 3 times, this is the divisor, this is what's out here, times the part that's up here, so 6x minus 6, and then we add our final remainder, plus 5. So then you do your favorite form of multiplication. Remember, we have to distribute everything. So we have 6x squared minus 6x. I'm going to set it up vertically, and I'll tell you why when I'm done. Plus 3 times 6x is plus 18x, and then minus 18, and then plus 5. Adding all our like terms, we have 6x squared plus 12x minus 13. This is the same as what's under here, so our answer is correct. Now notice, like here and here have the same thing. So if this 12x came out wrong, you could look back here to see if you multiply correctly. If you didn't multiply correctly, then you could look back here and see if you maybe made a mistake there. So if you can find where your mistake is here, sometimes you don't have to redo the whole division problem. So let's check this one. We have 3x minus 4 times 4x squared plus x plus 6. And then we're adding a remainder at the end. So 3x times that whole thing is 12x cubed plus 3x squared plus 18x. Minus 4 times this whole thing is going to be minus 16x squared minus 4x minus 24. And then we add a remainder at the end of plus 7. We have 12x cubed minus 13x squared plus 14x minus 17. So this is the same as what's under here, so our answer is correct. Again, we're going to check this one. We have 3x plus 2 times 3x squared minus 2x plus 5. Notice, because this has no remainder, this is actually a factored of, this is a complete factorization of this. Now let's multiply to check. So we have 3x times that whole thing, so we have 9x squared minus 9x cubed minus 6x squared plus 9x. And then 2 times this whole thing is 6x squared minus 4x plus 6. That becomes 9x cubed. 6x squared plus 6x squared is 0, plus 5x plus, oh, that was a 5 at the end, wasn't it? So this should be 10, so plus 10. That was a quick, oh no, did I make a mistake? Nope, I didn't, because I just rewrote something wrong. So this is the same as this, so it checked out. This is called a complex fraction because it's a fraction over a fraction. But remember, fractions mean division. So we're going to take this long division sign here and write 4/3 divided by the denominator, so 16 over 21. This is exactly what we saw at the beginning of this section. So that becomes 4/3 times 21 over 16. And now we can take out any common factors. So 16 and 4, we can take a 4 out. 3 and 21, we can take a 3 out. So we have 7/4. This one is a little bit more complicated because it's not a fraction over a fraction, it's an expression over an expression. So the first thing you have to do is simplify the numerator and simplify the denominator. Or we can multiply the whole thing by a common denominator. So the first thing we're going to do, so we're going to do case 1 and simplify numerator and denominator. So if we simplify the numerator, we have 8/5 minus 4. We need our common denominator to do the addition, so that becomes 8/5 minus 20/5, because we have to multiply by 5 over 5. So that becomes -12/5. And then 7/6 plus 1, that's our denominator, multiply by 6 over 6 to the 1, and we have 7/6 times 6 over 6, which would, or plus 6 over 6, sorry. That is 13/6. So this fraction is actually then -12/5 divided by 13/6. And then we can do the same thing we did before. So that is -12/5 divided by 13 over 6. So that's -12/5 times 6 over 13. There's no common factors in numerator and denominator, so we have to just multiply. So that's -72 over 65. And we're done. The other way to do this, case 2, is multiply by the least common denominator of the whole fraction. So our least common denominator of the whole fraction is 30 because of the 5 and the 6. So we're going to multiply numerator and denominator by 30 over 30. So that becomes 8/5 times 30 minus 4 times 30 all over 7/6 times 30 plus 1 times 30, because we distribute everything. This distributes in, that distributes in. 8/5 times 30 is 48, because it's the 5 and the 30 divide out. 30 divided by 5 is 6. 8 times 6 is 48. Minus 120. 4 times 30 is 120. Over 30 divided by 6 is 5. So it's 7 times 5 is 35. Plus 30. 1 times 30 is 30. So then we have -72 over 65. Some methods of this work better than others. Sometimes it's easier to do case 1. Sometimes it's easier to do case 2. Sometimes it doesn't really matter. Like in this case, it didn't matter too much. Sometimes it is easier to do one or the other. Now, this looks much more complicated, but it's really not. This is a fraction over a fraction. So this is the same thing as 4x squared y over 15x, that should be y squared, not y squared in the exponent, divided by 2y over 5x. So again, the first thing we want to do is flip our second fraction, so that's 4x squared y over 15xy squared times 5x over 2y. And now we do what we've done for all kinds of things, all of the other sections. 4 divided by 2 is 2, so we can take out a 2. 15 divided by 5 is 3, so we can take out a 5. And then if we want, we can multiply the numerator. So we have 2x cubed y divided by 3xy cubed. So then we have 2/3. And then there's x cubed divided by x would be x squared. Y divided by y cubed would be y squared in the denominator. So it's 2x squared over 3y squared. That 3 didn't look very good, that's why I rewrote it. And that even was worse, but you'll be okay. All right. So now this one. Again, you can multiply, you can simplify the numerator, simplify the denominator, and then multiply, or we can multiply by the least common denominator. So first we'll do case 1. That's simplifying our numerator and simplifying our denominator. So we have 4 over z. We need the times 7 over 7 minus z over 7 times z over z. That makes our denominator 7z. So that's going to be 28 minus z squared over 7z. And then our denominator is z plus times z over z plus 2 over z is equal to z squared plus 2 over z. So then our numerator was 28 minus z squared over 7z, all divided by z squared plus 2 over z. I'm going to flip the second fraction when I bring it up, just to save some room. And I'm also going to erase this over here so that we have some more room to write also. So then we have 28 minus z squared over 7z times z over z squared plus 2. This is one whole thing, and this is one whole thing. They're not the same, so we can't divide anything out. But we do have a z in the numerator here and a z in the numerator there. So those do divide out. So our final answer is going to be 28 minus z squared over 7 times z squared plus 2. Case 2. Is multiplying by the least common denominator for everything. So our least common denominator is going to be 7z. So we're going to multiply by 7z over 7z. Remember, we're going to distribute. So 4 over z times 7z minus z over 7 times 7z all over 7z times z plus 2 over z times 7z. 4 over z times 7z, the z's divide out and you're left with 28, minus z over 7 times 7z, the 7's divide out, and we're left with z squared, 7z squared in the denominator, plus, here our z's divide out, plus 14. This, we could actually factor out a 7, right? So we have 28 minus z squared over 7 times z squared plus 2. This answer is the same as our previous answer. If you do it this way, you could leave it like this, or you could factor. But typically, in factored form is actually simplest form, because if we needed to evaluate a number, it's much easier to evaluate numbers here than it is here, believe it or not. That's it for today. See you tomorrow.